binary symbols, at least for to 15s, because in the test, in the exam, you should sometimes do some calculation and know these things, because you could not use calculators. So please memorize these tables, especially for binary symbol, but do not just memorize, understand how actually it goes. Okay, so sometimes we say that decimal symbol, we say that the base 10 system. Why? Because we have 10 digits from 0 to 9, it's 10 digits. Okay, and we call binary number system is also the base 2 system, because we have only 2 digits. Okay, so next one, very important to understand the concept of place value, because we often need to convert, from other system to the decimal system. For this reason, you need to understand what is a place value. For example, consider some decimal number 739. Yes, so actually we can represent it 7 times 100 plus 3 times 10 plus 9 times 1. So what is actually 100? It is actually a place value. So first, for example, imagine here we have point, then 9. 9, its place value is 1. It give us 1 units. So how can you calculate the weight? You just need to multiply 9 by the 1, because the place value of this position is 1. Next place value, it's 10. So 3 times 10, it will be 30. So next one, it's will be 100. So what will be first position on the level? What will be its place value? Can you say? For example, if we had here, after 7, if we have some digit, what would be its place value?
10.
1000.
1000, right? 1000. So it's very easy. So you need to just multiply by 10 each time. Okay, so here other examples. For example, consider the number 2475. So actually, first place value just units, 5, then 6, 7, it's tens, hundreds, and etc. So actually it's easy, it's understandable for us. But when we will do with the other number system, it will be a little bit complicated. But the pattern is the same to understand, because we need to just, we have the base 10, and you need to, for example, this first is 10 power of 0, 10 power of 1, etc. Okay, so let's consider place value for the binary system. Okay, so here, for example, you have some number 1101. So what does it mean in terms of decimal number? So for it, we need to understand the place value for the binary system. For example, let's consider it's our binary point. So to the left here, 1. So what's its place value? So it's just 1. Just 2 power of 0 is just 1. So next position from this point on the left, its place value is 2. The next is 4, 8. So you just multiply by 2. For example, here 1 multiply by 2, 2 multiply by 2, 4, and in any continue actually forever in this direction. Okay, so here now you can understand that this number 1101 in terms of decimal number, it will be just so this give us 1 item. Here actually we don't have nothing, it's 0, so we don't have items. Here we have 4 items, and here on the first position we have how much? 8. So this represent 13. So for example, here you can see other number, for example 11. So in the first position, just 1, here 1, but it gives us how much items? This one. Can you see?
2.
2, right, 2. So 1, 1 represent actually what number?
3.
1, 1 represent in terms of decimal, what number? 1, 1.
3.
3. So here 1, 0, 0. Here you can see that in the first position from the left, no, on the left side, we have 0, 0. Actually, it should give us 1, but here we have 0. For this reason, it does not give us any items. So this also 0, but it does give us 8. So 1, 0, 0, it will be just 8 in terms of decimal number. So I think
Is that 4?
this one, oh sorry, that it's 4. Sorry, right? It's 4. 8 will be if we will have here, and here will be 0, right? Okay, thank you for remark. Next one. So it's great that you should have some notebook. Yes, you need to draw, not now, but when you will do homework, please draw this diagram. It's very helpful because you will do a lot of calculations, and we'll need, for example, here we have some self-test. The 1 in the binary number 100 has a place value of in decimal. So what? So you can just see from this diagram that it's just 8 place value. So next one, the binary number 0101 equals in decimal how much?
10.
So let's check. 10. Next one, the binary number 100000 equals in decimal number
128.
Okay, I'm lazy to calculate this. Let's check.
32.
32. So how do we know? We just need to 1, 2, 3, 4, 5, 6 in this 1, 2, 3, 4, 5, 6, 32. Okay, so the binary number, it's a little bit more complicated. So who can say? Do not use calculator, just do it manually.
127.
How much?
127.
You did you calculate it?
No. Just 100.
1024.
No, it will be
200. Yes, 200.
200.
Yes.
So, okay, right. Next. So please draw this, but not now. After lecture, when we will do homework, draw in your notebook. So it's very nice diagram. So actually, it is on the book. So binary to decimal conversion. So I think now it is understandable how to convert. For example, you're given the binary number 1101110. What would you say it equals in decimal? So when I'll do it, by hand, just without calculator, just write down. For example, we can write down some box. It will be very convenient to do. So next, write down on the up, place value. Just wait. For example, first it's 1, 2, etc. So then you just here below you can just write the numbers. This give us 1. Here actually should be 2, but because here 0, it does not give nothing. 4, etc. So you just sum up, and you will find that this decimal number will give up 109. So I think it's easy. But so do you have question how to convert binary to decimal conversion? No? So you should understand just the place value. If you know the place value, you can just calculate it. For example, just here 2 power of 0, 2 power of 1, etc. So it's very easy actually. So next, the binary number 1111 equals in decimal how much? So you should use this is
15.
15, yes.
Yes, it's
Yes.
15. Right, it's 15. So the binary number, this one, 100010, it's too long to
34.
pronounce. 34.
34.
Okay, right. Excellent. So next, the binary number, I will not pronounce, it's too long. Equals in decimal. How much? So actually, what's the place value of this last number?
512.
522.
2 powers
Yes,
9.
so 522, right? Okay, so next. But when we need to convert from the decimal to binary conversion, we need. Actually, there is several ways, but I know one, and it's very simple. Procedure to convert decimal to binary is the repeated divided by 2 process. So, for example, we need to convert decimal number 158 to binary form. So for it, what we will do? First you will divide this number 158 by 2, and yeah, it's right. So it will be 79, right? So remainder is 0. So what we'll do? So this remainder 0 will be our first digit. So next, our quotient of 79. Then you divide 79 by 2, and you will get 39 with remainder of 1. So this remainder, it will be our second digit. So next we will continue. 39 we will divide by 2. It will give us 19, and with remainder of 1, this remainder will be third digit. Then we'll continue our dividing. 19 we will divide by 2. It will give us 9 with a remainder of 1. So we will place it here. Next, 9 we divide by 2. It will give us 4 with a remainder of 1. And of course we will place it here and continue. 4 divided by 2 give us 2, but in this case we don't have any remainder, so it give us 0. And next, what we will do, we will divide 2 by 2. It will give us 1 with a remainder of 0. And last, I think it will be 1 divided by 2. So actually it gives us 0 with a remainder of 1. So, and this remainder, it will be our last digit in the binary number. So when we get, we call this quotient. When the quotient will be 0, it's signal to stop. So that's it. So actually we converted decimal number 158 to the binary, counterpart, and it will be just 110111110. So I think it's simple, but you need to do a few examples, not just to understand, and do not forget how to do it. Okay, so let's do some tests. The decimal number 39 equals in binary. Do not use calculator, just take the paper and try to calculate. How much? Is it clear how to convert?
100111.
Let's check. 100111. Great. Okay. Next, the decimal number 100 equals in binary. But I think you can just say it. It's easy, right? It's decimal number 100, not binary.
1100100.
Of course, it should be in binary. Okay, so 1100. Okay, so decimal number 133 equals in binary. How much? Have you calculated?
I mean 100001101.
10001. Okay, so right. Okay, so now I don't think that we learned. I think you already knew this. So we just recall how to do convert. What is a binary? How to convert binary to decimal, decimal to binary, and also what is a place value. Okay, so what we're interested here in this course, it's how to translate this decimal number to the binary. Why? Because when we do some calculation by the integrated circuit, by computers, we need to, of course, convert to the binary. So for it, we need you should understand how we can do it. So of course, we need for this design some circuits that could able to do it. Okay, for example, when two people speak, for example, these guys maybe speak, I don't know, maybe Spanish, these guys maybe English, but they're monolingual. So for this reason, they could not understand each other. For this reason, we need some translator who will perform, this function. And in electronics, of course, we have some, not equipment, some digital circuits that do it. For example, it is some keyboard that has numbers from 0 to 9, yes. And our goal, to convert it to the binary. So for this, we need some device that we call encoder. So it's the function of the encoder is to convert decimal to the binary. Then we can process this binary number. We can do it, some calculations, store, etc. Then, for example, we need to do, opposite function. We need to decode. So we need to decode this binary to the decimal, because for example, here you have some output display. For example, you press 9 and it encodes to some binary number, equivalent binary number. Then maybe it's going on some processing. Then the decoder will give us show just on some screen or display that we human can understand. So it's just simple device that we will do on the lab by the Multislim. Of course, for encoder and decoder, we will use some definite integrated circuit. So, but you should know, and I also suggest you to write down. But if you can handle it now, we can do it fast now. But after lecture, you should write down this definition. For example, what does it mean decode? Decode to translate from encrypted code into more readable form. For example, converting binary code to decimal. So this means decode. It's a verb. So decoder is some logic device that translates from binary code to decimal. So generally, it makes the conversion from processed data in digital system to a more readable form, such as alphanumeric. So decoder give us just more readable outputs than it was input. For example, input must be for example, binary, and output will be decimal. Encode is verb to translate or encrypt. So actually, encode and encrypt, it should be synonyms. So encode to translate or encrypt, for example, converting a decimal input into binary code. So please write down this definition. Encoder is logical device that translates from decimal to another code, such as binary. So in general, it converts input information to a code useful to digital circuits. So we use in the lab work, so we use a decoder. We will use encoder and actually convert. Of course, unfortunately for now, we can do it only by simulation, but I think next maybe students who will study this course next year, you know that in university just new and we don't have yet all equipment. So now I hope that in the next year we'll have some hardware, and you still will be on the third course, and you just if you will get, you can come and also try to do it, not by simulation but also by using real integrated circuit and etc. Okay, so actually what this kind of thing you will do in the lab works tomorrow. So I already mentioned that keyboard, for example, encoder for the encoder you will use integrated circuit that 74147. So in the multislim there is this integrated circuit and you will use it. So but this actually this encoder give us not, for example, if you press 7, the output from here will not be the real binary 7. It will be inverted. For this we need inverters. So why it happens, for your course it doesn't matter. If you're interested, you can go find some electronics books and understand why it's happened. But you should understand when we'll use this encoder, your output will not be, for example, if you press 7, for example, if you press, just 1, you imagine that should hit would be 1, but it will be 0. So we need to invert, and for this reason we need inverters. So in labs we will use this integrated circuit 7414. So then from the inverters it goes to the decoder that will that connected to the output segment, and that give us this representation of our number from 0 to the 9. So actually this kind of labs you will do tomorrow. So here, for example, we press 7, input 7 of the integrated circuit is activated by low. So this you should understand. So actually on the input we have some high value, for example 1, but when you press 7 you activate. When you press 7, here will be low, and all of this stuff, there's some procedure how it works, so you can also see it is on the book. So step 1, you press activated by low, then what encoder outputs inverted binary. For example, for 7 it will be 1000, but 1000 it's not 7. So inverter changes inverted binary 100 to real binary. So what actually it's doing, just 0, it converts 0 to 1, 1, 1, and 1 to 0. So 0, 1, 1, it is a 7 in the in terms of binary representation. Okay, and next it's decoder converts from binary to 7-segment LED code by driving lines to segment. For example, it will drive A, B, and C segment. And now we will see this LED display and understand that somebody pressed 7. Okay, so let me show you. Guys, do you have some questions? Can you hear me, see? Is it okay?
Yeah. I have a question.
You can ask if you have some questions.
Why is the low? Like, if we put 7, why is activated by low?
Okay, now I will show you the circuit. It's a very nice question. So I open. Can you see my multislim?
Yes, yes.
Yes.
Okay, so now I will open this circuit. For this reason, I need. No, it's not here. Okay, it's this encoder. So it's just my design. It doesn't mean that you will do the same. So actually, with here I don't use this what is it? I don't. For now, for lab, we don't use this 7-segment LED display, but we'll do more simple one. For example, now I will simulate, and here you can see that now it's all closed. So this actually, this switch, it is my keyboard, okay? So 1, 2, 3, and you can see that now, for example, here 5 volts. So actually 5 volts go to the input. Here also 5 volts. So then, for example, when I press 1, you can see it connected to the ground, and here you can see that ground goes to the input. So I activated by connecting to the ground. Now, can you understand the answer to your question?
Yes.
Okay. So for example, here you can see when I press, last one will be light. So it's 1. Okay. For example, now I press, for example, 2. 2, it will be 1, 0, right?
But why is activated low?
What? What
But
activated?
it's activated like low.
Because here, look, it is a switch. So switch, it is connected to high and to low. So when it's high position, for example, now it is in the switch in the high position, and for example, for the 2 it goes high. When I press, can you see? It is connected to the ground.
Like he's going to through the low position, you mean, or?
No. So actually here we have, okay, let's see in more detail. So it's our integrated circuit.
Teacher, may I make my opinion? Like, as I understand, all the keyboards are activated at the beginning, and the action will be according to the when you switch off, like when you deactivate that, for example, button, that switch.
Yes, actually, when we start, you know, first me explain this. So actually, inputs is from 1 to 9, okay? So output is just A, B, C, D. So, and when we assemble this circuit, you should, you know, apply to the from these pins, from 11 to, from this all of the pin 11, 12, 13, 1, 2, 3, 4, you need to apply high voltage. You need to apply the 1. Then, so actually here you can see why it's moving. I don't know. For some reason it's okay. So now my switch all closed. So actually to the input, I apply 1 to each input. I applied 1 with high voltage. So next, for example, I push, for example, this button 2. In this case, you can see that I here in this position I apply 5 volt, but then when I push, I apply 0. So actually here it is designed like such a way that you activate not by high value, you activate by low value. Okay, so when I put 2, you can see that my second LID is lights. It means 1. It doesn't light. It's 0, 0, 0. So it's 1, 0. It's 2. For example, I press 3. So you can see that 1, 1. This LID and this LID is lights, and 1, 1. You understand? It's 3. That's it. So for example, I press 8. It's 1, 0, 1, 1. When I will press 9, what will be here?
1001.
1001. Okay, so this integrated circuit 7414SN can, just convert decimal number to the binary number. Okay, so let me show you. But there is something interesting with this integrated circuit. For example, when I press 2 button, for example, 2 and 3, it understands only this high position. 3 is larger than 2, so it will understand only as if 3 is pressed. For example, if I will activate 4, it will read as if 4 is pressed, not 2 or 3. So, but why it's happening, it's not the realm of our digital system course, but your goal to, utilize this integrated circuit and just assemble this simple device that can convert when you press, for example, some button. If it is 3, you should design the systems that will show that it is in binary, it will be 3. So for example, if I will press 3, it should 1 1. Okay. So what else I want to show you? It's decoder. So a little bit different. So I need to stop this one. Okay, I will activate. So it's decoder. So actual input, but you should understand that here we have some, we can only, our input can be only 4-bit information. That's it, because we have only 4 input. So for example, if I press this one, it means 1. And here you can see my LED that represent 1 lights. For example, I will press here 1 0 0 0. It means 8. So you can see my light that represent my LEDs represent 8 will light. For example, 1 1 0. It should be 6. That's so. Tomorrow you will should assemble.
Can I ask?
Yes, you can ask.
What happens if you do 1 1 0 0?
Let's try 1
1 1 0 0, because it's
1.
more than 9.
It will not light because we only restricted to the 9.
Oh, okay.
For this reason, you need to assemble other. You could not do it by this system. Okay, how much time we have? 10 minutes, yes? Okay, so also let me show you other interesting schemes that also we'll do tomorrow, and then we'll continue with other other numbers in digital electronics. And let me open. Also, you need to tomorrow assemble some counter. In Russian it will be счетчик. So actually, here I have some generators that give me. Actually, you know it. You already assembled in the last labs. It's just free running multi vibrators that continuously give us digital signal. So actually, this circuit can count in binary numbers. For example, so I will start. So actually, it should work. Doesn't count. Why it's interesting? let me. So it starts, okay. So actually it's just count how much, this generator give us impulses. So actually it counts how much impulses goes to the integrated circuit. So it's very interesting work.
So
But it
now
was,
this circuit automatically adds 1 to the previous number.
yes,
Increase
it's
by 1.
so. For example, if I will press, it just will reset. So, for example, when I press this one, it will count because here this generator give us, series of impulses. So I'll start, and we'll count 1, 2, 3, 4. Actually, it's a basis of digital clock that we all have. It's a basic. It's a counter. Okay, tomorrow on the lab, I already, uploaded to the Moodle, so please review these 3 works. At the end of the lecture, also I will talk about it. Okay, so let's me stop and let's continue with. Can you see my slide?
Yes.
Yes.
Okay, hexadecimal numbers. Hex, it means, I think it's 6 hexadecimal numbers. So it's very useful because, it's very easy to convert from the hexadecimal numbers to the binary numbers. So the hexadecimal number system uses the symbols, 16 symbols. So from 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then we need to come up with other symbols. So it just, letters was added, A, B, C, D, E. So it has 16 symbols. So, and we also, call it the base 16 system. So, for example, here's some decimal number and binary representation. So actually you can just represent, for example, binary not just by 1, 1, but you can, write 4, 0. So actually it doesn't matter because the first numbers matters, but if the last one is 0, you should not, just count it. So I think now it's clear. 0, 0, 0, 1, 1, 1. I think up to the 5 it's okay. So it's the same. Decimal and hexadecimal is the same up until 9. Then not 9, up until 10. Yes. Or maybe it's so 111. Look, we don't have. We need to come up with new. I think I made here mistake, right? So
There
actually,
should be A.
yes,
like-
sorry guys. So I made mistake. It should be A, B, C, D, F. Okay, so actually you can check these tables on the book. So after we need to come up with. Okay, sorry for that. A, B, C, D, E. A, B, C, D, E. I forget E. A, B, C, D, E. I forget E. So actually here should be A, B, C, D, E. So do not pay attention to the table. Check on the book. Okay, so why we use hexadecimal system? How can we convert to the binary or to the decimal? So first of all, I already mentioned that the advantage of hexadecimal system, its usefulness in converting directly from 4-bit binary number. For example, you have number C3, the 16 base. It's our hexadecimal number C3. So we need to convert to binary. So actually it's very easy. You know, you just write down separately each digit, 3, and you can actually check from the table previously I showed you, and you see that 3 it's 1 1 0 0 1 1. So you write down it, and then separately you see C and just check the table, and you can take 1 1 0 0. So it's easy to convert. So C3 it's actually 1 1 0 0 0 0 1 1 in binary. So opposite conversion is also very easy. For example, you have this binary number 1 1 1 0. You have question 1 0 1 0. You need to convert to hexadecimal. How can you do it? Also, you just need to consider 4-bit. So this 1 0 1 0 it's first 4-bit, and 1 1 1 0 it's second bit. So just consider separately and convert first 4-bit to the hexadecimal digit, and second bit 4-bit to the hexadecimal. That's it. So it's nothing, you know, some special. It's very easy to convert. So actually, people who work with the programming for microcontrollers, they use hexadecimal, you know, number a lot. So because of this easiness of to convert from the hexadecimal to binary and vice versa. I think for now we can, you know, stop for a while. Now we'll have some short break, 10 minutes, right? Or 20 minutes? How much?
20.
20. Okay, so if you have some question from the for the first part, you can ask, and I will try answer. But I want to talk with the guys who now on the quarantine. Are you here?
Yes.
So guys, you need to do lab, because we will do a lot of labs. So last ones we actually did 3 labs. So tomorrow we'll do also 3 labs. So it's already 6. So my suggestions for you now only one. Just search internet and download this Multislim program, you know, and do it and upload to the Moodle.
So by the way, teacher,
Yes.
at the beginning of this week, I could see the homework on Moodle, but
Mhm.
at this moment I cannot see.
For the first week, do you mean?
Yes, like there were assignment. Yes, there was assignment on Moodle.
Okay, let's let me open.
You've opened the university site, not Moodle.
So I need to sign in. Can you see my screen? Yes?
Yes, yes.
Okay, so let's go to my courses. So here you can see homework week 1. So it is the first introduction to digital system, just first slide. Then also we have lecture 1, second slide. So it's a course book, it's a copy of course book. So download it. So lab work, it's the assignment for the lab work in the PDF file. So it is a homework, you know, just if. So read chapter 1 of the course book, Digital Electronics Principle and Application, pages 123. So answer chapter review questions. So you need to answer these questions on the pages 23 to 24. It should be written, you know, answer and submit here. That's it.
So, teacher, can I show the assignment tomorrow? Because I haven't know this course. this course delete or something like that?
Do you want I show you for tomorrow?
Yes, tomorrow we have offline lesson. So I could not submit my
Yeah,
assignment
tomorrow.
to Moodle.
Yes, tomorrow we'll have. You could not submit.
Yes, because there's no exact this course in my Moodle. I have another digital system course which is not written as Baujan Ilyasov. There was written only vacancy and it's empty there.
What's group?
IT 2001.
So I think you need to go to the office register and ask them to add you to this, because I don't know how can I add you.
Okay, I will do it, but the deadline is passing, so that's why I am asking you
Yeah,
to show it tomorrow.
in this case, who could not just send me by email, okay?
By email, okay.
Yes, just write down your full name and group. And so guys, here you can see week 2. So now presentation for this test lecture, lab work, homework. So homework I've already showed that. It's also read chapter 2. There is questions, answer and submit.
Teacher, can I ask something?
Yes, yes.
I'm really sorry that I passed the last lesson. I didn't attend on the first lab work. Should I submit something, or you will just give grades of the quiz for the place of first lab work?
No, yeah, anyway, you should accomplish the lab 1. So if you missed, okay, you have some reasons, but you can do it, yourself and just.
I should submit something, yes, to the place of lab work 1.
Yes, you need to perform 3 labs works and submit on the Moodle. If you don't have any problem with submission, you can submit.
Okay, thank you.
Or send me by email if it's some problem on the Moodle.
Sorry.
Okay.
Okay.
My group is on quarantine,
Mm-hmm.
so we can't present at the class tomorrow.
Yes, I know. For this reason, I said, guys, download Multislim. Please download Multislim and install on your computer and do it yourself.
I think it's not free. So some I calculate.
Yes, it's not free, unfortunately, but one way it's just find some cracked ones. I don't know. When I was a student, I always can find a way to. I know it's illegal, but
Just download from torrent.
so if you could download from torrent, okay, you can. But if you don't want, okay, it's okay. I will not insist. So in this case, if you will quarantine, when we'll back from the quarantine, okay, then you can do it at the university. Just go to the labs, open, sit on the computer, open the Multislim and do it after your quarantine, okay?
Teacher, can I ask you?
Yes.
So in Moodle it's written like our labs 1 is overdue by 6 days. Is it okay? Whereas we did it in offline.
What do you mean by overdue? It means some restriction for the.
Yes, in Moodle. Can you see?
Okay, I will see change this data. Okay.
So you are already marked us, yes?
Who did in the?
Because we already did it labs in offline format.
Who did on
Yes.
the offline format and showed me on the class? I already marked on the Moodle. You can see.
Okay. So it's not necessary to submit something else, yes?
So it's better to submit, because then maybe can be some misunderstanding. For example, I can forget, you can forget, and you can just show me that you submitted. That's it. So just trace, your work.
Teacher, you have said that you mark us in offline, yes? And put the grades in the Moodle.
Yes, who showed me all 3 works on the lab works, I graded.
But I have shown it and I see my grades. I have no grade.
Same stuff.
Okay, you can show me tomorrow and I will grade you, okay?
Okay.
Вы
Teacher,
помните, говорили 50 поставим? 50.
So I thought, but it will be too difficult and to convert. For this reason, I will just, you will get, at least every week you will get 2 grade, 1 for lab, 1 for test. So additionally, I can, grade for homework, for other, assignment, but 2 stable grade you should get. It's for lecture, 1 grade, okay? And for every test, 1 grade.
Teacher, in the first week, why we have 2 lab works?
No, we have actually, because they are all connected with each other. We studied multivibrator, but there is 3 types of multivibrator: a stable, monostable, and also what kind of free running? What other? Monostable, bistable, yes, 3 kind of. So actually, 3 labs, you need to separately assemble these 3 types of multivibrators. But also, we assemble 2 types of multivibrators and the bouncing switch. So 1 circuit, it means 1 lab.
One circuit, one lab? One lab?
For example, here you can see 1 circuit. It will be, for example, lab work, but lab work can contain several works. For example, tomorrow you will do this encoder. It will be lab 2.1. Then you should assemble decoder. It will be lab 2.2. Then you should assemble counter. It will be lab 2.3. That's it.
Yes, we did 3 lab works exercise in the last.
Yes, so I just call lab, for example, I will, for first week, I will call, for example, just lab 1, but it doesn't mean you will have only 1 circuit. It means that in this lab, you can have, for example, 3, maybe 5 circuits. So for this reason, I just subdivide. So just check the PDF file and it's clear from the PDF file.
Okay.
Teacher who is in quarantine, what's the deadline to the first lab work, or we can do it after the quarantine?
Guys, actually, I don't have strict, some deadlines. For me, Moodle is also new, so give me some time. I will see this data and rearrange. So do not worry about deadlines for the lab works, because it's new, Multislim, it's new for you. So do not worry. Okay?
So we can do it after the quarantine, yes? Or first lab work?
For the guys who are on quarantine, if you don't opportunity to install the Multislim, in this case, you can then when you come back from the quarantine, then you can show me. Do not worry about that.
Teacher,
Yes.
On the previous offline classes, I didn't save. I have not saved the tasks, but I show it to you, and you say that it is acceptable.
Do you mean you did not save your Multislim files?
Yeah.
Oh. But have you shown me all 3 works?
Yeah.
All 3 circuits?
You gave me 15% over 100.
In this case, I already marked you, so do not worry.
Okay.
So do we need to switch to another link, right? Because we have 2 links on the schedule.
Yeah.
So in this case, guys, I will end this this meeting, and you need to join to the next, okay?
Have a break? Oh, what?
We already have break.
Okay.
So please go to the next